Hello everyone, welcome to video lecture on software architecture and design pattern. Today we are going to discuss third module, design pattern catalog. Now we should discuss about several issues should be considered when applying the decorator pattern. So first one is interface conformance. So here the issue is the first one, interface conformance. Actually the decorator object interface must conform to the interface of the component it decorates. So actually we have the example, that is the concrete decorator classes must therefore inherit from the common classes. So that issue will be considered whenever we are applying the decorator pattern. So the first one, interface conformance. The second one, omitting the abstract decorator class. So this issue is very need to be taken in the considerably applying the decorator design pattern. There is no need to define in this actually an abstract decorator class when we need only need to add one responsibility. So this is the very important. So we should omit the abstract decorator class in such cases, because whenever we need to add only one responsibility not required. So these issues will be considered. Why? Because whenever we are dealing with an existing class hierarchy rather than designing the new one, it is waste of time, cost, all everything will be considerable. So actually the thing is in that case what you can merge decorator responsibility for forwarding request to the component into a particular concrete decorator. Okay. Now the third point, so keeping component classes lightweight. So this is the thing where we need to take consider in the issues, that to ensure conforming interface like that component whatever the decorator must be descend from a common component classes. So it is very important to keep this common class like always be a lightweight. This is better for this the component classes for when we implementation purpose. So another thing, in case of the defining interface or on the storing part or data, so that should be considered. So here actually the definition of the data representation should be actually differ to the subclasses always. Otherwise, complexity of the component class always might make the decorator too heavyweight to use the in a quantity wise. That we need to count. Another, putting a particular lot of component into that increases the whatever probability of the concrete class. So in the future, if they don't need it in that cases, so keeping component classes lightweight is always a considerable issue while applying the decorator design pattern. Now coming to the fourth point, changing the skin of an object versus changing its guts. So here what does it meaning, that actually we can think about a decorator as a skin over the object changes always its behavior. That we need to think it, we need to understand in that what actually skin over changing its guts. So an alternative is to change for guts. Actually we have an alternative part, this issues regarding the implementation purpose, a strategy pattern. Actually it is a very good example of a pattern for changing the guts whenever the guts is there in the skin part. So the object skin, that strategy pattern is very suitable. Even the strategies are better where to add that, where the component class is intrinsically heavyweight, they were making the actual decorator pattern too costly to apply in that case. For example, so we can support different, for example, border style having the component border drawing, separate border, what we say that object, or the border object is the strategy object that encapsulate a border drawing strategy, scrolling strategy, whatever it is. By extending that, the number of actually strategies from just one to open-ended list. So this is the way we need to consider, because this decorative pattern only changes the component from the outside, the component which doesn't have to know anything about our decorators. So that's why we say that decorators are always transparent. Decorators are transparent to the particular component. So this we will see it in the even object in the object component so this is the we continued with strategy component. So decorator extended functionality. So here we have that decorator followed by component and decorator and followed by component. This is the extended functional decorated function of the extendability. So that again component. So here actually with the strategies of the component itself knows about possible extents, so it has to reference the maintain the corresponding strategies. So that's why we have taken this component followed by component in the sense strategies, then followed by a strategies, that is followed by the next, then followed by a strategy, then followed by next. So here strategies extended functionality, this part. So here we have taken decorator extended functionality taken. So that is the strategy based approach might always require modifying the component to accommodate new extensions. On the other hand, what we say there, strategy can have its own specialized interfaces, whereas decorator interface must conform to the components. And in the other case, a strategy for rendering, for example, we need only defined interface for rendering drop order, get width, height, left, top, bottom, whatever it is, which may strategy can be lightweight even if component class also having a heavy weight. That is the strategy will be very useful. So next, after this implementation issues, next we need to go with the sample code. This code part just we will discuss briefly what and all. The following actually code snippet of code will be taken in C++. We assume that component called class called as visual component we have taken in that one. So class visual class public component void draw void. This is the simple snippet of code will be taken. So and after that we need to define so visual component called decorator, that is our actual decorator classes, which will subclasses obtained from the different. So class, decorator, public, visual component, and virtual void draw resize. So whatever it is, so that can be taken. That is the sub coding part of the sample code will be given in the text. Okay, noun users, we say that many object oriented user interface toolkit uses decorator to add a graphical embellishment to the widget. So finally, so example or there are a lot of include interviews, et++ and an object works or a small talk class library. There are a lot of decorator debugging glyph from the interviews to the festivity wrapper on the Parl place small talk. It depends on that is the noun users. A lot of noun users will be available. Decorator pattern gives that use an elegant way to add the responsibility to the streams. There are the stream level, memory stream, file stream, and stream decorator. So and followed by ASCII 7 stream compress stream, which is extended functionality of compress data in buffer. Stream decorator of handle the particular paper. So that all will be we should consider in the noun users. So example of that one ASCII 7-bit all ASCII 7-bit, we decorate a file stream with compressing the stream of ASCII 7-bit. How we are going to take all the particular noun users, and what are the suitable related pattern for this decorator pattern is a decorator pattern is always different from an adapter pattern. Adapted in that decorator only changes an object responsibility, not its interface. So this is related to that one. An adapter will give an object completely with new interface. Actually, composite so in case of comparison related to the composite, a decorator can viewed as a degenerate composite with only one component. However, we can say the decorator add additional responsibilities. That is the thing. Compared to that one related to the strategies, a decorator lets you change the skin of an object strategy, which strategy lets you change the guts. This is the way. There are two alternative ways of changing the object. So this all comes under the related patterns. Next, we will move on to the another structural design pattern is faked structural design pattern. So the next structural design pattern is the faked structural design pattern. The purpose or intent is provide a unified interface set of interfaces in a subsystem. Actually, the package defines a higher level interface that makes the subsystem easier to use. So the main intention or the purpose of the package structural design pattern is to we should make the entire subsystem easier to easy, which is very easier to communicate all the subsystem and subclasses of whatever the object is declared or defined. So there is no other name of these fake kits, or we can say other name well known names is not there, also known as not there for fake kit. Directly we will move on to the next part with the example of motivational example, that is the motivation sections. So we will look into that motivation. Actually, the structuring a system into subsystem, we know that helps to reduce the complexity. A common design actually one our goal is to minimize the communication and dependency between the subsystem. That is the main goal of this structural part. So one way to achieve this goal, what we do, we introduce a faked object that provides a single simplified interface to the more general facilities of the subsystem. So that is the one way what we can do it very in the better manner. So this is the what we have here, the client classes. This is the structuring into the subsystem. So actually what our aim or our goal is to reduce the this communication complexities or dependency between the subsystem here, there and there. So when you adopt or apply this faked introduce faked design pattern, so this is the client classes, client 1 2 3 whatever it is, n number of clients. So what they are expecting, they are going to the common pool here. So these packets will communicate each other inside that one, which will make the very easily which communication or any dependencies. So that is the communication will be minimizing so the dependency between each subsystem. So that is the added advantage of this packed design pattern. So here consider for example a programming environment. We know that gives application access to its compiler subsystem. We have taken that one. This subsystem contains a class such as scanner, parser, program node, bytecode stream, program node builder, etc. that implements the compiler. When you consider here, actually the subsystem, if you consider compiler is the main, and the rest all assume that it is a subsystem. So what will happen here? We know that so the subsystem contains a class such as scanner, parser, program node, bytecode, whatever it is that implement the compiler. So here specialized application might need to access these classes directly in case of all the subclasses. So but most of the client compiler generally don't care about the details like parsing or code generation. There are some part that client is not really interested. They are not really interested, or they are not bother about it, because which will communicate each other in the generalized structuring subsystem. So that is the drawback, or what we can say, that is the drawback of that one. So for them, for what they expect, for them the powerful but low level interface, the compiler subsystem only complicate their task. So this is the case actually to provide higher level interface that can shield the compiler, what is the shield client from these classes. So compiler into the particular main compiler classes. So in that case, the compiler here, when you apply this facade, the compiler class act as a facade. So when entire compiler which act as a facade class or facade design pattern, so it offers clients a single interface, whatever the client expects interface to the compiler subsystem. So that is the what we can say, the compiler facade makes life easier to easier for most programmer without hiding the actual low level functionality from the few that need it. Actually they need it. So this is the one part, because major thing we will be considering this, because otherwise there are certain clients they don't need everything in the part. Okay, next we will consider this part, but most what the client generally don't care about. So, okay, we want to compile the code, whatever it is. So we have already taken that is the compiler subsystem also include compiler classes in this case. Okay, this class defines here unified interface to the compiler functionality. So that is the major part. Actually, the compiler subsystem also include a compiler classes. This class actually define a unified interface, that is the common interface to the entire compiler functionality. So now this is the compiler subsystem classes. So this entire diagrammatical representation or uh, a structural diagram of the motivational example what we have taken here. Just assume that this compiler act as a, we had seen that we said that compiler act as a compiler class, and you consider this which will compile to scanner, and that will be generated to token. Similarly, compiler class will have the parser. Again, this will have the program node builder. Again, program node will have the particularly symbol and token. So this program node again will be generating that what is the statement node, expression node, and respective variable nodes. Okay. Similarly, compiler class, which when it acts as a facade, so this will have the code generator classes. Okay, subclasses that will converted once again that will be converted to bytecode stream classes. So this bytecode stream will be again converted into the stream classes. So this is the way, but this actually when a compiler acts as a facade, so wherever it is required, that information only it is communicating, and it is what the client request, client 1 or client 2, client 3, client whatever there, client request which will be fetching the information to that. So here code generation will have the subclasses again there to what is that one? Again, subclasses of this one, stack machine code generator, again RISC, risk code generator. So like that, which will be communicating to the each other. So the that is the what is the using of our facade design. So actually the compiler class act as a facade. So it always, what we are saying, what we said, that it offers client a single simple interface to the compiler subsystem. This we can call it this entire compiler subsystem classes, what we are calling it as. So it glues together, we can say that it glues together the classes that implement the compiler functionality, whatever the classes that implement the compiler functionality, without hiding them completely. So we are not going to hiding in the faked design pattern. So that is the specialty of this faked structural design pattern. So here one more thing, the compiler faked makes, we said that is life easier because the any without hiding the lower functionality level here for the fewer that need. Because so when you take this scanner will be generated token like that parser. So whatever that program node will have the program node builder node. Again, this will be, there is no incomplete details we are getting here. Program node will have that statement node, expression node, variable node, whatever the information, and where need to communicate between from one class subclass to the another subclass along with a particular object. So everything we will be getting into the facade. So that's why we had that one, structuring a system. This is the entire compiler subsystem. If you consider structuring system into subsystem, help to reduce the actually complexity. So that is our common goal, is to minimize the communication. So here this entire compiler, so compiler act as a facade classes. When the compiler class act as a facade, that is including subsystem classes also. So that is a very easy to communicate each other subsystem classes, whatever the here subsystem like bytecode stream code generator and stream classes, stat, whatever the subsystem communicate whenever is required client. So we need to communicate with directly to through this entire compiler subsystem classes. So this is the major thing. That's why major purpose of this compiler class is the example we have taken compiler class, that faked design pattern is mainly provide a unified interface to a set of interfaces in subsystem. This is all set of interfaces, because unified interface is a compiler. So what it does packet, this compiler subclasses is a defines a higher level interface that makes the subsystem is easier to easy, so easier to use of particular part. So that is the considerably we can the programming environment give the application access in the compiler subsystem, that we know that scanner, parser, program node, bytecode stream, program node builder. So whatever so and so that specialized applications always we have taken which need to access these classes directly without disturbing any part of that. So we can be taken. So this is the skeleton or the motivational example we have taken as a compiler and subclasses. So this is the part, what is that one, compiler class we have taken, that is the one our structural part. Later we will take in the skeleton part of the this faked design pattern. So because we have not taken any other example in this text also, so need not be any word will be a statement of that or label will be not required for the skeleton part of this compiler part, that is the faked structural design pattern. So next we will see that one. So that is not required, because this is a general just passing that how that subclasses will be communicate, and if you make it as a one of this as a faked classes, when you make it as a faked class, just communication how it is going to communicate connection diagram, just representation is enough for this, need not be add all the labels. So that is the beauty of these compiler classes. So that we can actual structure we will see in the next video.